Hello, my name is Sandeep and welcome to my YouTube channel. Today I am super excited as I am taking you to an interesting end-to-end machine learning project for building an AI application for chest cancer detection. This can be a classical example of how AI can be used for the medical fraternity, especially for the doctors and radiologists, with a quick diagnosis of any health problem or disease. In a situation where a doctor or radiologist has to visually and manually check each and every chest CT scan image out of many and then uh, take a decision on that, comment on that. In that case, an AI based application like this can be quite helpful and it would reduce their stress. Also, it would further help them with the prioritization of cases. For example, in case suppose patient is not detected with the cancer, it is a case of normal chest. In that case, they can give it a less priority. In case cancer is detected, they have to give more priority to the case. Like that, they can prioritize the cases. From the patient's perspective, definitely if chest cancer is detected at the early stage, so treatment can be also started early and life can be saved. So in this project, our goal is to first train an AI model with the CT scan images, especially chest CT scan images of the several patients. So build and train an AI model with the chest CT scan images of several patients, and then later making predictions for any new chest CT scan image of any patient, unknown patient from any unknown data set, and making prediction for that. So here we'll be training one convolutional neural network or deep learning model with the training dataset images for chest CT scan, and also we'll test and evaluate it with the several test images, chest CT scan images, unknown chest CT scan images from other patients. So here, after training the model, we'll evaluate, as I have mentioned, and then after that we'll build one web applications for this chest cancer detection. After that, we will deploy onto AWS ECS on the Amazon cloud as a containerized application so that other people can access it and see it. So let's get started. Okay. So for this project, basically our goal is to predict if the patient has cancer, chest cancer or not. And if chest cancer is detected, what kind of chest cancer this is. So here, basically it will detect if the patient has chest cancer of these types, these three types, any of these three types, in fact, adenocarcinoma, large cell carcinoma, squamous cell carcinoma. So I'll just basically briefly explain them. So adenocarcinoma is the most common form of lungs chest cancer, accounting for 30% of all cases overall and about 40% of all non-small cell lungs cancer occurrences. Adenocarcinoma of the lung are found in the outer region of the lung in glands that secrete mucus and help us breathe. Symptoms include coughing, weight loss, weakness, etc. This type of lungs cancer occurs mainly in people who smoke or used to smoke, but it is also most common type of lungs cancer seen in the people even who don't smoke. Second type is large cell carcinoma. This type of lungs cancer is named so because of its large abnormal looking cells. Large cell carcinoma lungs cancer grows and spreads quickly and can be found anywhere in the lungs. And it also makes up to 10 to 15% of all non-small cell lungs cancers. Third type is the squamous cell carcinoma. Squamous cell carcinoma is another large cell carcinoma and is sometimes referred to as the epidermoid carcinoma. This type of non-small cell lung cancer usually begins in the middle structure of the lung or center of the lung, like the bronchi. Squamous cell carcinoma, it also make up about 1/4, means 25% of all non-small cell lung cancers. So basically there are three types of chest or lung cancer: adenocarcinoma, large cell carcinoma, squamous cell carcinoma. The model is going to predict if chest cancer is there and what is the type of the cancer out of these three, or if the patient is not having like chest cancer, so it will predict as normal chest. So it's a multi-class classification problems. So we have 4 classes. Now I will briefly show you the data. So I am in my project folder for chest cancer detection, and I will go to the data directory, and I will take you to the train folder, where you will find all the chest CT scan images for all these 4 classes: adenocarcinoma, normal chest, large cell carcinoma, and squamous cell carcinoma. I'll quickly show you the CT scan images for chest. This is for the adenocarcinoma. This one is for large cell carcinoma. This is for the normal chest patient without any cancer, that is normal chest. And this one, these images correspond to the squamous cell carcinoma. And similarly, in the test of validation data set also, you will find this kind of images, chest CT scan of several patients, which corresponds to all these 3 types of chest cancer as well as the normal chest. Since for training this kind of model, especially complex convolutional neural network or CNN model, deep learning model locally on our local system, it's difficult to train them the local system, because since it requires a lot of memory and also processing power. So I decided to train it, build the model and train it on Google Colab. So since here you have the option of using GPU, so you can make your training faster. So dataset was downloaded from the Kaggle, as you can see, and so after mounting the drive here, the Google Colab, then we are importing all the necessary libraries here. So we are using TensorFlow library as a deep learning model, and deep learning for building deep learning model using TensorFlow library, and then all other necessary methods or functions we are just importing from the Keras. Layers are pre-processing, etc. So for example, the image data generator that we are importing, this is used for image augmentations. Suppose you have the training images of 4 classes, so you can make the training data set more diversified. You can add more variety to the images. That means you can augment the images actually using image data generator. So here in the image data generator, for both training and test dataset, basically we are rescaling the image, means we are normalizing the pixel values of the images by dividing with the 255, so that the pixel values will be between 0 and 1. And then for this train data gen, as you can see, the rotation range, width shift range, height shift range, etc., all these things we are specifying here. Shear range, zoom range, horizontal flip, vertical flip, both are true. So, and then training set, we're defining here train data gen dot flow from directory. Here this is the training folder which contains all the training data set images, just CT scan. and our target size is 224 by 224, means all the we are reducing the image sizes to 224 224, width 224, height 224 for all the images, training images. So same thing we are doing for the test images also here, and batch size is 64, and class mode is categorical. Since we have 4 classes, so class mode will be categorical. So after defining the training set and test set, as you can see, 613 images are there which belong to the 4 classes, and here for the test or evaluation we have 72 images which belong to 4 classes. So I first built one CNN model from the scratch, convolutional neural network model from the scratch, and then I did a lot of experimentation, and I could achieve good accuracy on the training data set, around 85%, 90% accuracy on training data set, but test data set I could not achieve better than 75% with my own CNN, convolutional neural network. Then I decided to go for like transfer learning. That is another technology, transfer learning, where you can use some existing neural network or some existing CNN model. For example, I tried with the BGG 910 ResNet also, but I found that BGG 16 was better. So then I decided to use the BGG 16, and here, as you can see, we are setting the include top equal to false, means we'll be only using the bottom layers, mostly convolutional layers, and the max pool layers. Those layers will be using, but we won't be using the top layers. So include top equal to false. Top layer means fully connected layers that we won't be using. We'll be building our own fully connected layers or dense layers. So it is a part of the Keras application, this BGG 16 model, and then it was trained with the famous ImageNet dataset. So weights will be ImageNet. So after defining the base model and basically downloading the base model, we are freezing the layers, means layer equal to layer dot trainable will be false, means we are not going to train anything here. Just that is why we are setting the layer dot trainable equal to false. So after that, we are just getting the output of this base model, the CNN equal to defining the base model dot output, because this output, base model output, will be our starting point. We are starting from here to build our own model or neural network. So if you look at the shape of this, it's basically 7 by 7 by 512, and it is a tensor, Keras tensor. Then we are flattening it to make it just a vector, which is one-dimensional array. So after flattening, it will be 7 into 7 into 512. So it will be 25,088, as you can see it from the shape. So after flattening it, then we are building our own dense layers. Input dense layer, we are specifying 1024 neurons, and activation will be ReLU. And then we are using dropout in order to get rid of the overfitting problem. So where 20% of the neurons will be dropped out. And then for the output layer, so number of neurons will be 4, since we have 4 classes. It's a multi-class problems, basically 4 class problems, classification problems, and activation will be softmax. And since it's a multi-class problem, activation function, we are using softmax for the output layer, and then combining the base model dot input. This will be our input to the model, and then output will be the CNN. This one we are combining this both input and output. We are just building the model, and then after building the model, we are compiling it. For compilation, you have to specify that optimizer. We are using that famous AWS optimizer. Then we specifying some learning rate 0.001, so that neural network will be trained smoothly. There will be less fluctuations, and there won't be much overfitting also. And loss function will be categorical cross entropy, since we have 4 classes. Matrix will be accuracy matrix. And then after that, the model dot fit, here we are starting the training, and so model will train on the training data set, and then we are monitoring the both accuracy for the training data set as well as the validation or test data set. So as you can see, when training was going on, so it is showing the accuracy. This is training accuracy, and this is the validation and testing accuracy. And then So after a lot of experimentation, trial and error, and a lot of hyperparameter tuning, I could achieve good and accuracy on the training data set, around 87.2%. And on the validation test set, it was 80.56%, around 81%, which was good one model. Then I decided to go for this one. And then I saved the model as a Keras model H5 and downloaded from the Google Colab. Once it is downloaded on the Google Colab, it is in my full control. And so I could test it further or evaluate it further locally on my local system, that is laptop. So for testing, I created this script, chest underscore cancer underscore prediction .py. Here basically we are first reading this image, and this is squamous cell carcinoma, one PNG image. Actually this is this image corresponds to one chest CT scan of a patient actually having the squamous cell carcinoma cancer. So after we are reading it in the CV2, that is OpenCV, and then here also we are loading the model. It's a Keras load model, this saved model, and then we are resizing the image to 224 by 224 because model accepts image of 224 by 224 pixel size, and then we are converting into image array, and then we are expanding the dimension. That means adding one extra dimension which is required for the model, and then we are normalizing the pixel values by dividing it by 255, the image pixel values. After that we are just making the predictions by passing the image to the model, and then basically it will be in the form of some probability score or confidence score, and then and also there will be levels or indexes, and so depending on the index also the probability or the confidence score, so prediction will be accordingly made, and it will be either adenocarcinoma cancer or large cell carcinoma or normal chest or squamous cell carcinoma cancer. So after testing it locally and after getting satisfactory results, and then I decided to build one web app using Streamlit library in Python. And so for that actually I'm first importing all the necessary libraries, and OpenCV, that is CV2, Streamlit library, NumPy, from Keras models we are importing load model, then Python imaging library also we are importing the image from PIL, and then couple of functions are there here. First for loading the image and displaying the image on the app. So for that we are using this image function from the PIL, Python imaging library, for opening and displaying the image. After that we are creating one function here, chest cancer prediction. This will predict the chest cancer. So here we are passing the image, and so we are supporting both the image formats, PNG and JPG. So accordingly it will first save the image in some local folder, this process directory, and after that it will read in the OpenCV, and then it will also load the model, and then it will basically pre-process the image, like resize it, and then all these things that I have already explained, then normalize it also, and then after that it will make the prediction, and then after making the prediction it will return the whatever prediction it is, like whether it is normal chest, whether it is adenocarcinoma cancer, large cell carcinoma cancer, squamous cell carcinoma, etc. And also the confidence score with which model is predicting this confidence score or probability score, it will also return. And after, in this main function, we are building this Streamlit app, web app for chest cancer prediction. As you can see here, we are setting the background color, then style, all these things, that font size for the text, and it is AI app for chest cancer prediction, as you can see. And after that, basically upload, one can upload a chest CT scan image. Here upload chest CT scan image, and we are supporting the JPG, PNG, and then it will only support the JPG and PNG, and accordingly it will check, and accordingly first it will, once you upload the image, chest CT scan image there on the app, it will first upload and display the chest CT scan what there, so one can see there also. And then after that there will be one button called predict. You will have to click on that, so it will basically the model will predict the cancer, and and it will show you the prediction and also the confidence score for that. What kind of cancer it is. If cancer is not there, whether it is a case of normal chest, also the confidence score for that. So in each category, it will show you the prediction as well as the confidence score for the same. So after building the app, I locally tested it, and then basically here, as you can see, I'm running the app here locally, and then I'll just quickly show you the app. It's a very nice looking app, but simple app. So chest cancer prediction, AI app for chest cancer prediction. And here drag and drop files here. So you have to just click on browse files, and for example, one unknown chest CT scan image. But I know it's a cancer, it's a case of chest cancer, but basically, let's see how this model is predicting, app is predicting. So after you upload the file here, image file, it will show you the name of the file, and also it will display the image over here. And after that, after loading is complete, and it will show you the button, predict button. You have to click on the predict button. Then it will make the predictions and also give you the confidence score for the same. So now it's a bit slow. So yeah, so you can see the predict button. So once you click on the predict button, so yeah, so model has predicted it has a adenocarcinoma cancer, and confidence score for the same is 97.9%, almost 98% confidence score. So this is the confidence level, or confidence score 98%, or probability score with which model has predicted that it's a case of adenocarcinoma cancer. So I'll do few more predictions here. For example, this is a large cell carcinoma. We know it's a known case of large cell carcinoma cancer, and let's see how the model predicts it. So I am click on that predict button, and yeah, it is also predicted as a large cell carcinoma cancer, and confidence score is 89.70%. Almost 90% is confident that it's a case of large cell carcinoma cancer. So it is correctly predicted. Now let's upload one chest CT scan image for a normal chest, for the example this one, and let's see how it does. So it's a normal chest image, and I'll click on predict, and let's see what model says. So our AI model says that it's a case of normal chest correctly, and confidence score is 99.98%. So like that it works. So after building the app and locally testing it, then I decided to deploy it onto AWS ECS, that is Amazon Web Services, ECS, Elastic Container Service, as a containerized applications. So for that, you have to Dockerize the applications, means you have to, create a Docker image of the entire applications. So I'll show you for that you have to create a Docker file, which I already created, and as you can see in the Docker file, if you see, just you have to, all these commands you have to specify one after another from Python 3.9.0, then exposing port number 8501, which is Streamlit port. Then you have to create one directory user app, and then set it to as a working directory, the user app in the Docker, inside the Docker container, and then copy all the files to this folder. And after that, you have to just run apt get update to update the dependencies in some libraries, and here also install some more libraries, and most importantly, using pip command, you have to install all the required Python libraries. If you look at the requirement, it is NumPy, TensorFlow, Keras, Pilo, OpenCV, Python, Streamlit, all these required libraries you have to install it, and that it will do. And at the end entry point, you have to specify Streamlit run, and then the name of the app, that is chest cancer detection.app. So I first build this Docker image locally, and also then I ran one Docker container from these images and locally tested the app from this Docker container actually, and it worked very fine. Then I decided to deploy onto Amazon, that is a web service AWS ECS as a containerized applications. So for that, one has to follow certain steps, and I followed all the steps. First thing, you have to install the AWS CLI command line interface, and then on the console you have to do AWS configure. Once you do AWS configure, it will ask for your access key and secret access key. All this you have to provide. Then AWS will be configured. But I forgot to mention that before creating Docker image, you have to install the Docker desktop. It is very important, and then also launch the Docker desktop, run the Docker desktop. Then from the command prompt, you can like build your Docker images and test it. In my case, already Docker image is already there created, and I just need to follow the certain step on the AWS. First, log on to AWS and go to ECR, Elastic Container Registry. Okay, so for example, first go to the ECR, Elastic Container Registry. Yeah, so Elastic Container Registry here. Then after going there, then you have to create a public or private repository in ECR. In my case, I created public repository in ECR. So after creating this repository, you have to go to view push comments. So in my case already it is created. So you have to just select it and go to view push comments after creating. So it will show you step by step what you need to do in order to like push your Docker image to this registry. So first thing is a retrieve an authentication token and authenticate your Docker client to your repository using AWS CLI locally or command prompt here. So this you have to this command you have to execute AWS ECR public get login password and region US East 1, all these things. So after that, after you are done with this, then next thing is you have to build this Docker image, which in my case already I have created a Docker image. And so after creating Docker, you have to tag it. You have to tag it. So for tagging, just give the name of your Amazon ECR name, actually Elastic Container Registry name. Tag it with Amazon AWS ECS ECR. Elastic Container Registry, AWS ECR, you have to tag it, and after tagging, you have to push it using the Docker push commands. So once you push it, and then you will see it here. It will appear here, your Amazon ECR repositories, and then here chest cancer detection project here, latest image tag. So this is the Docker image that we have pushed here. You can click on that, and so here basically you have to copy the URI. This is the location of this Docker image on the ECR on your Elastic Container Registry repo, Elastic Container Registry repository. So yeah. So we have already copied the image, Docker image URI path from the ECR repo. Now next thing we need to create ECS cluster. Okay, so Amazon cloud service cluster, ECS cluster. Go to ECS and click on the clusters and create EC2 Linux cluster. In my case already I have created EC2 Linux cluster, and specify cluster name, EC2 instance type, and give other things at default and create it. So after that, you need to create the ECS cluster. In my case already I have created these clusters. So with the EC2 instance, yeah, I have created the clusters. and EC2 Linux cluster we have created. And then we have you need to view the cluster. Already we have viewed. And then next thing we have to we need to go to the task definition on Amazon ECS and create a new task definition. This is very important. We have to go to task definition and create new task definition. In my case, already I have created task definition. So after creating the task definition, okay, for creating the task definition, you need to, under Amazon ECS, you need to click on new task definition and choose EC2. You have to choose an EC2 and specify some name for this task. And you have to specify task memory, CPU, etc. And this add the container. This is very important. So from the copied URI path, you can specify the location of the container, specify container name, also the container name, image, container image location that we already know. So we have to specify the port number 808501. We have to keep everything as default and click on add. Container will be added. After that, we have to click on create and to create the task. So we have just created a task definition. So after creating the task definition, then you have to go to the clusters and go to task, and you have to go to task, and then you have to click on run new task. In my case, already task is running. So once you click on run new task, after clicking on the run new task, you have to choose EC2 as a launch type and keep everything as a default and click on the run new task. The task will be running. Your task will be running, and on the clusters, your task will be running. So basically it will be running the app, this cancer detection app from this container image, Docker container image, which is there in the ECR repo. So it will be running on this cluster, ECS cluster, which we have created. So it is running. So now after that, we need to go to EC2 dashboard and click on the instances. After that, we need to go to the EC2 dashboard. We need to EC2 dashboard to check if it is instance is running. Number of instance running is 1. Click on that. So click on the instance ID. So you can see that check the instance state, it is running. So once it is running, so you have to click on the public IPv4 DNS. So you have to click on the open address here in order to launch the app. But before that, one very important thing is that you have to go to the security and then go to the security group. You have to then basically edit. You have to edit the inbound rules. It is very important. You have to change it to from the custom to anywhere IPv4, and then you have to save the rule, save the changes. So after that, you have to go back to ECS, and then you have to again click on running instances, and then instance ID, and then you can open it. In my case, it is already running here, and by default it will be running with the HTTPS secure. You have to change it to HTTP. Just change it to HTTP, and then finally you will find that you will see that your app is running on Amazon Web Service AWS ECS as a containerized application, and anybody can access it or use it through browser, as you can see. So that's all for this video. I hope you have enjoyed it, and if you have liked my video and liked the content, please give like and write your feedback or comments. I'll be very happy to see them. And please subscribe my channel also. Thank you very much for watching my video. Thank you. Bye bye.